Alright, the second section in Chapter 4 of the calc book is implicit differentiation, which is basically taking the derivative of equations. So taking derivatives of equations when they're not set up as y equals. Okay? Remember, when we take the derivative of y, when it's set equal to y equals, we get dy dx. So it's a variable that we have to take into consideration. So when you do this type of problem, like number 1, we have to treat y as a variable, treat y as a function of x, and then we have to, because of that, use chain rule. Okay, so let's see what happens here. If I'm just taking the derivative of the equation y squared equals x, we know the derivative of x is just 1 because we're taking with respect to x. The derivative of y squared, though, we use the power rule first, so this comes down just like if it were an x squared. So we have 2y to the first power. However, y is a function of x, not y. So now we have to take the derivative of y and multiply that by the inside. So now we're taking the derivative of the inside, which was y. The derivative of y is dy dx. So I did the power rule and then took the derivative of the inside. And that's equal to 1, because the derivative of x with respect to itself is 1. So to solve for dy dx, you just divide by 2y, and you get 1 over 2y, when y cannot be 0, clearly. Alright, so let's keep doing some of those. Find the slope, again, which is dy dx, of this circle at the point 3, negative 4. Well, do the same thing. Take the derivative of the equation as written. Derivative of x squared is 2x. And then times the derivative of x, which is 1, so you don't have to do that. Plus, power rule, it's 2y, but you have to, y is not x, so you have to take the derivative of the inside, which is dy dx, equals 0. Do not forget to take the derivative of 25 and make it 0. Sometimes people leave the number there. We get 2y times dy dx. You can also use y prime, and I will start doing that going forward. It's just easier. And then we divide and we get dy dx is equal to negative 2x over 2y, or you can say it's negative x over y. Well, it says find the slope at the point 3, negative 4. We plug that point in. Negative 3 over negative 4. The slope is 3/4 at that point on the circle. Okay, let's keep going. Show that this slope is defined at every point on the graph. Okay, well, first we have to find the slope, and in order to find the slope, we have to take the derivative. Now you have to be careful because there's y's on both sides. Alright. This is to the first power, so it's just going to be 2, and the y's the y's not gone completely. If it was 2x, it would just be 2, but it's 2 times the derivative of y. So the derivative of 2y is 2, and then I'm going to call it y prime, which is, again, what we're looking for. Equals x squared just becomes 2x. Don't have to do any derivative with that because it's with respect to x, plus the derivative of sine is cosine of y. Again, since we took the derivative of y, we have to multiply by the derivative of y, which is y prime. Now, remember, when you have two y primes, you need to get them together. So I'm going to move the cosine y prime over. So I have 2y prime minus cosine y times y prime equals 2x. The reason why we move them over is now we can factor out the y prime and have it as a single piece. And so we can then solve for the slope, which is y prime, is 2x over 2 minus cosine of y. The question is, show that this is defined. Well, in order for it not to be defined, is the bottom has to equal 0 somehow. So the question is there ever a spot where 2 minus cosine of y equals 0? And the answer to that is no, because you guys should know what are the values you get for cosine of y. The domain of this, or the outputs of this, actually, the range, we would get values from -1, output, to 1. So 2 minus either -1, 0, or 1, or anything in between, can we ever get to 0? No, we have to have a 2 there. Cosine of y, I could have, I guess, done that as well. We could also say cosine of y needed to be 2. And that can never work. So therefore, it is defined for all points on the graph. Okay. Now, again, we've been doing this, but let's list the process we've been using to find these things. The first thing is differentiate both sides. Of the equation with respect to x. Then collect the terms with the y prime on one side of the equation. Then factor out your y prime, and then solve for y prime. Okay, so let's see what happens here. Let's do a more difficult problem here. We have find the tangent and normal lines to the ellipse, x squared minus xy plus y squared equals 7. You guys should recognize that this is actually a rotated ellipse because of the xy term. Remember when we did those rotations? Everyone loved those. So we're going to just take the derivative because, again, in order to make an equation for a line that's tangent and normal, we need a slope. So you have to be careful, though, here. Let's take a little quick look here. We have two variables being multiplied together, and they're different. You need to do product rule here. I'm going to just write that out right now so we see that, so we don't forget to do that. Alright, so let's differentiate the whole equation. X squared goes to 2x minus, okay, now I'm going to do the product rule. I'm going to use just x and y. So if I don't take the derivative of x, the derivative of y is y prime, plus take the derivative of x, which is 1, times y, plus 2y times the derivative of y, which is y prime, equals 0. Okay, so I'm going to rewrite this as 2x minus xy prime minus y plus 2y y prime. I'm going to keep the y primes on this side and move the other stuff to the other side. It really doesn't matter much which way you go here. So I'm going to, my y prime pieces are the 2y y prime minus xy prime equals, if I move the y over, that becomes positive y. If I move the 2x, it becomes minus 2x. Okay? I factor out a y prime, and I get y prime times 2y minus x equals y minus 2x. Divide. Y prime equals y minus 2x over 2y minus x. So that's the slope. However, we want to know what the slope is at the point -1, 2. So now I'm going to plug in values for those, which is equal to 2 minus 2 times -1 all over 2 times 2 minus a -1. So 2 plus 2 is 4 on top. 4 minus a negative is positive 1 is 5. So the slope of the tangent is 4/5. So the equation for the tangent line is y minus 2 equals 4/5 times x plus 1. And the equation for the normal line, we just opposite reciprocal the slope. I don't know if that was really a verb that I just used there, but you guys know what I mean. So these are the two answers. Again, the whole process is finding the slope by taking the derivative. Okay. Last thing, we're going to do higher order derivatives. You can find the second derivative So let's do that. So let's take the first derivative. Let's find the first derivative. And we get 3 times 2 is 6, x squared, minus 6y to the first, but then times y prime equals 0. So I solve for y prime. I move the x part over. So you get that y prime is equal to, the negative 6's will divide and cancel. It'll just be x squared over y. So that is the first derivative. Now we need to take the derivative of this. Well, you guys should know what rule do we have to use here. The way it's set up, this would be a quotient rule. Okay? Or you can move it up and make it a negative first y to the negative first, and do a product rule. But that is, I'm going to use quotient rule here. So, the second derivative is equal to low, which is y, times the derivative of the high piece, which is 2x, minus the high piece, times the derivative of the low piece, which is y prime, all over what's squared below. Okay, so we have this. And some of you guys might be thinking, that's great, I'm done. No, you're not yet, because this problem, when you take the second derivative, I only want x's and y's in there. And unfortunately, I have a y prime. However, I do know what y prime is equal, so we can now sub it in. So, I'm going to say that the second derivative is equal to 2xy minus x squared times x squared over y, all over y squared. And then to clean it up, well, I'm going to separate these pieces real fast into two fractions. So you get 2xy over y squared, minus you get x to the fourth over y squared over 1. And so our final answer is, these y's cancel, you get 2x over y minus x to the fourth over y cubed. And that is equal to the second derivative. Alright, good job. That is how you do implicit differentiation.